Thanks for watching the third edition of Henry AI Lab's AI Research Weekly Update video. Following this introduction video, we're not going to cover the blog source to aggregate the content for the video, but they will all be linked in the description below. This week we're going to cover things like exploring weight-agnostic neural networks from Google's AI blog, DeepMind's release of Openspiel, reinforcement learning games environment, and DistillBERT, a model released from Hugging Face that uses knowledge distillation to distill the BERT model for reduced model size and faster inference time. Thanks for watching this video. Please subscribe to Henry AI Labs for more deep learning videos, particularly in September with a focus on neuroevolution, using evolutionary and genetic algorithms to optimize the weights in neural networks, explore different hyperparameter configurations, and do the exciting task of neural architecture search. The first blog post covered in this week of AI Research Weekly Update is a release from Hugging Face, DistillBERT, a distilled version of the BERT model. So the trend in natural language processing has seemed to be to build bigger and larger transformer language models, whether that means being trained on enormous amounts of text or if it means just having tons of parameters like NVIDIA's Project Megatron. So this chart right here shows the trend in increasing the size of natural language processing models, specifically models based on the transformer architecture, which is presented in the paper Attention is All You Need. So DistillBERT is going to look at a technique to reduce the model size. So whereas this Megatron model from NVIDIA has 8.3 billion parameters, this model only has 66 million. So they begin their article by motivating why you might want to reduce the size of models, attributing to things like on-the-edge inference, like in IoT devices, or running it on a smartphone, which are usually memory constrained and need fast inference time. So some of the popular techniques for reducing the size of neural networks are quantization, where you replace the weights of a network with a lower precision data value. So rather than maybe using like a 32-bit floating point, you would use maybe like 16-bit or 8-bit. And then weights pruning, which is where you remove some of the connections in the network that have small values. And then the technique that they're going to focus on is model distillation. Model distillation was made really popular in this paper by some of the all-stars in deep learning, Jeffrey Hinton, Aurelio Vinyals, and Jeff Dean, which is a technique where you take a teacher network, which is a really big deep neural network, and you have it predict the labels on classes, and it predicts a distribution over the logits. So it might predict, say, 0.8 airplane and like, 0.1 truck, and then like 0.002 cat. So this is called, they call this dark knowledge, how the teacher model it has this distribution over the classes. So in model distillation, you're going to train the student network, which is a much smaller neural network, to predict the same distribution as the teacher rather than emulate the classes directly. So they do this for the transformer, and the way that this looks is in things like predicting the next sentence the next word in a sentence like this. I think this is the beginning of a beautiful blank. The teacher model predicts this distribution over the next word. So see how it says day 21%, life 18%? So they're going to train the distilled version of BERT to predict this probability distribution over the tokens rather than like a 10000 type of thing. So the way that they're going to transfer the knowledge is by using things like this soft cross-entropy loss, and they're going to compare the distributions of the teacher logits and the student logits using a KL divergence loss term. KL divergence and things like Jensen-Shannon divergence, these are metrics to compare distributions. So if you're comparing a probability distribution compared to a vector with a set of fixed values, you would use something like a Kullback-Leibler divergence loss function. So they distill the BERT into distilled BERT, and they still reach basically the same amount of performance, although they only have half the layers. And overall, they have about 60% of the parameters in their model compared to BERT. So these tables show the performance of distilled BERT compared to the original BERT and compared to a baseline that doesn't use the transformer architecture. So this baseline uses the OMO embeddings with the bidirectional LSTM model. And then they also show the number of parameters used and the inference time achieved with DistillBERT. Then they also show the success of the model on the IMDb review sentiment classification when it's fine-tuned for this task. And they show how well it does when it's fine-tuned for question answering. And then they propose another idea of further distilling the model by having the language model that was trained with knowledge distillation be fine-tuned with distillation on the BERT model, fine-tuned for question answering. So overall, this is a really interesting study on how we can reduce the size of these massive transform models, which makes them more accessible, more available to use in smartphones and IoT devices. And overall, it's a really interesting research study. From the Google AI blog, we have Exploring Weight-Agnostic Neural Networks. Weight-agnostic neural networks are a really interesting study that shows that a neural network where every weight in the network is the same can perform really well just by searching for the right combination, the right connection of the individual neurons, all sharing the same weight. So this image right here shows sort of the difference between these networks. You have networks like the one on the left that are fully connected. Every neuron is connected to every other one that performs just as well as this sparsely connected network found with the weight-agnostic neural network experiment. So they show their algorithm for how they find the weight-agnostic neural networks using the NEAT topology search algorithm, which is where you start from a minimal network. You have the option to insert a node or add a connection or change an activation. And then they have, in the NEAT algorithm, they have all sorts of other nuances that you can look into if you're interested. So they show overall their evolutionary algorithm search for the weight-agnostic neural networks. And then they show a visualization of how the architecture performs on the cart pole swing up task. And this task is trying to balance this pole above the cart, and it shows how it performs with these different random weights assigned to every weight in the neural network. And then they show how the fine-tuned network performs. So the weight-agnostic neural network is fairly successful, but it's still not as good as the fine-tuning of the weights. And then they also show how well it performs on the car racing and give you a visualization of how that looks. And they hint at how the weight-agnostic neural network is really naturally extended to ensembling networks because you're randomly assigning them all the same weight in a given interval. So say from -2, -1 to +1 and +2. So you can easily ensemble this with the same architecture and the same weight. And they also, in their conclusion, talk generally about neural architecture search and the bottleneck of having to train the models with stochastic gradient descent to get them to convergence. So, for example, in the reinforcement learning neural architecture search paper, they have to train their child models for, say, at least 25 epochs on the CFAR10 dataset before they know how well the architecture performs. But in this kind of search, they all use the same weight. So you just discover the architecture and then bang, plug them in for inference. So it's an interesting approach to thinking about how you structure your neural architecture search algorithms, and this technique will really speed up the evaluation of the candidate models. And then also they point you to their library, their implementation of NEAT called Pretty NEAT, which is an interesting repository showing how to evolve neural networks for the OpenAI gym tasks like the cart pole balancing. The next blog post from the Google AI blog is Bitempered Logistic Loss for Training Neural Nets with Noisy Data. So the idea in this paper is to address the binary cross-entropy loss function, or the logistic loss, by accounting for data points that are on the boundary of the class that might result in really stretching out the decision boundary to try to fit these points as well, or in addressing points that lie sort of as outliers on this side of the decision boundary. So this research introduces these T1 and T2 additional loss terms to help smoothen the decision boundary and avoid being pulled by outliers. So this shows different values of their T1 and T2 parameters to control the binary loss function and how much it pulls the decision boundary in either case. And also they introduce a visualization where you can interactively see how the T1 and T2 loss functions help you adjust to different noise levels in your data set. So in this case, we have a small margin noise, meaning that it's like kind of on this boundary compared to large margin, which would mean it's like all the way on the outside like this. And then you can see how you increase or decrease the temperature values to account for the noise in the data set. DeepMind released Openspiel, a framework for reinforcement learning in games. Similar to things like OpenAI's Gym and Google's research football environment, this is an environment to interface reinforcement learning and control algorithms with. So what this environment is it contains about 20 implemented games of single agent and multi-agent, zero-sum, cooperative and general sum, one-shot and sequential, turn-taking, simultaneous move, perfect and imperfect information games, and partially and fully observable grid worlds and social dilemmas. So this has many games. They have a lot of instructions on how to install it and get started with it. This is their list of games implemented, like Backgammon, Connect 4, And then the status implements how thoroughly they've tested the environment. So, for example, the coin game and cooperative box pushing haven't been thoroughly validated. And then they show some of the algorithms that they've implemented as well to interface with the games if you want to try them. So again, it just shows, it also has an extendable API if you want to add your games into the Openspiel environment, which is pretty interesting. You can also check out Openspiel on GitHub, where they have a list of tutorials on installing Openspiel, an introduction to it, and then like a first example getting started with the framework. Shown here with the Coon poker game. From the Stanford AI Lab blog is an explanation of their work presented at ICML 2019 on policy certificates and the previous work on PAC bounds, probably approximately correct bounds, and things like I think regret bounds. So basically the idea is that, probably best shown in this image here, is that the existing probably approximately correct bounds say things like across many episodes they have these guarantees. They say the AI system treats at most 7,000 patients badly, the rest is guaranteed to get almost perfect treatment. But you don't really have any kind of bounds for individual episodes. So the idea with their policy certificate algorithm, which they discussed like the real details of it more in the post as well. But the high level idea is that it's tailored more specifically to each episode to give you like a confidence interval on each episode rather than just a bound across many episodes. So this is definitely an interesting component in reinforcement learning. It's an interesting thing for earlier from the MIT Computer Science and AI Lab blog, we talked about how reinforcement learning is used for data center efficiency. And in this case, you would be able to get a confidence interval on certain workloads, and then maybe a human could intervene and use like a manual algorithm or something if the confidence bound is too loose or, just generally not good. Starting off with Facebook AI's research lab, we have more news on natural language processing. This article is about research awards granted to different natural language processing projects from Facebook to people in academia. So these proposals were all either in the topics of computationally efficient natural language processing, like the Distilbert model from Hugging Face that we looked at earlier, neural machine translation for low resource languages, and robust deep learning for natural language processing. So it's definitely interesting to just read through these, learning to screen, accelerating training and inference for natural language processing models, efficient deployment on edge devices. Definitely just looking through this, and you can also get a sense of the proposal and the overall summary of like what they're after with these kinds of things. It's definitely interesting to follow these people and see what they're doing, and overall I think just having this list of researchers doing these interesting projects, it just helps everyone stay on top of the new advances in natural language processing. Also from Facebook's AI blog is the open sourcing of hyperparameter auto-tuning for fast text. Fast text is a library that is used for text classification, and you use it by inputting a data set, and it can do things like spam detection, sentiment analysis, or smart replies. So this open source hyperparameter auto-tuning tool uses the Nevergrad library. So Nevergrad is a set of techniques like differential evolution, sequential quadratic programming, down to particle swarm optimization. So what this does is it basically is an auto-tune, a searching technique for finding the right parameters for the fast text language models. IBM Watson's blog details some exciting ways that AI can help improve the experience at the US Open. Some ways that they propose are using an Ask the US Open chatbot that can help fans navigate the tournament and do things like live scores, match schedules, and weather updates and more. More interesting though is their AI highlights dashboard. So what this does is it has like a computer vision and an audio analysis system that watches the games and then can automatically make highlight reels from the tennis matches in real time using this AI highlights system powered by IBM Watson. So this is a really cool future of the sports experience. It'd be really cool to see it go from tennis to other sports like basketball, football. Overall, it's a really cool use of AI, computer vision, and IBM Watson. MIT's Computer Science and Artificial Intelligence Lab posted a blog post about their rowboat project, which is an autonomous navigation boat that can shape-shift according to different obstacles. So in the article, they describe the motivation, Amsterdam's canals, applications like turning into pop-up bridges and stage platforms or collecting trash and transporting goods. So this research was presented in the IEEE Multi-Robot and Multi-Agent Systems conference, and overall they show some videos of how it navigates, and you can go to their page, robo.org, and see videos on their progress, like this one where it is using the computer vision system to navigate around these obstacles. Also from MIT's Computer Science and AI Lab is this article on how AI can help data centers run far more efficiently. So running data centers more efficiently is a huge opportunity for saving money and reducing the environmental impact of enormous server farms. And this is one of the biggest applications of reinforcement learning right now. So they describe the algorithm, which is a technique for managing workloads across different servers. So basically they have these directed acyclic graphs of the different nodes representing the like a different computation, and edges representing sort of like the order in which they have to be processed. And the reinforcement learning algorithm has to figure out how to distribute the workloads across the servers. So compared to things like operating system algorithms like first come first serve, round robin scheduling, and shortest job next, the reinforcement learning algorithm doesn't use any of these hand-coded algorithms. Rather, it sort of learns through trial and error how to allocate the resources throughout the processing of the workloads. So this is probably better described in their research paper, Learning Scheduling Algorithms for Data Processing Clusters. So basically the workloads are represented like this. You know, the edges says basically the child node can't run until the parent node has been completed because it needs that data. And then they describe how they use graph neural networks to vectorize these directed acyclic graphs. In reality are like enormous. They're things like Google's data center. So overall, it's definitely a really interesting way towards green AI and saving tons of money. Just things like they say how even 1% of efficiency can save millions of dollars in energy in data centers. And overall, they describe how their system is 20 to 30% on average and twice as fast during high traffic times. NVIDIA's deep learning blog details Dishcraft, a robotic startup that's looking to make washing dishes easier. So in the article, they briefly discuss how their robotic system works, but in the deep learning world, they use a computer vision system that uses cameras to inspect the dishes and sort of monitor how well they're doing, do a quality inspection on the robotic washing system. So their system uses the NVIDIA GeForce RTX 2080 Ti cards, and they also discuss how they use local GPUs and AWS with NVIDIA's V100 GPUs for training. So it's definitely a cool application. You can watch a video of how the system works and how they use the vision system to inspect the dishes after they've been washed by their robotic system. NVIDIA's deep learning blog also details a digital assistant startup that is looking to use video and analytics to help care for the elderly population. So what this is it has a camera mounted on the ceiling, and it uses computer vision and deep learning to analyze videos to tell things like if a patient has fallen, or if to give them reports on their activity, which is sent to the caregivers. Following along the trend of blog posts this week from NVIDIA's deep learning blogs in computer vision applications such as inspecting if dishes are clean, elderly patient activity, we finalize with vehicle condition inspection. So they discuss this startup that is using a computer vision system where you just need to take a single video around the car, and then it can calculate the cost of repairs that need to be done on the vehicle and what kind of damage has been done. So this is another really interesting application of computer vision and how NVIDIA's GPUs are accelerating the training of these systems. This week's edition of The Batch from DeepLearning.ai begins with a note from Andrew Ng about their trip to Colombia and their efforts to build an AI hub and their offices in Colombia. Following this is news about the Cerebrus chip for AI and deep learning. So this Cerebrus wafer scale engine is an enormous chip aimed for use in data centers. So they're predicting that it's going to be 100 to 1,000 times faster than the current GPUs. And just the size generally, it's 56 times larger than NVIDIA's current top-of-the-line GPU, and it's bigger than a standard iPad. So this chip contains 400,000 cores and 18 gigabytes of memory right on the chip. And if you've experimented with deep learning, you know how important it is to have this kind of memory right on the GPU chip. So this kind of size is equivalent to 84 GPUs communicating with each other 150 times more efficiently than they currently can. And this is because the memory is right on the chip. You don't need to be doing so much data bandwidth and communication. So overall, this chip is a really interesting development in deep learning. It's definitely going to have an enormous impact on the space when it's released. The batch also covers the Google Research Football environment, which is an environment for training reinforcement learning agents to play football in these kinds of simulations. So this environment was originally released on June 7th by Google AI Research. It has, in addition to just playing the overall game on levels of easy, medium, and hard, it also has these little practice scenarios where you would just be like 2-on-1 or 3-on-2 type of situations. So it's definitely an interesting environment. You control the player, you have these kinds of actions. You can choose how you represent the game state, for example, a vector with 115 features, or the full pixelized frame, or a super minimap of coordinates and speed of every player as well as the ball. Following this, the batch covers how to use AI and how AI is being used to help solve problems of interpreting astrology data, especially in real time. So this isn't something that I'm very knowledgeable about, so I'd recommend just clicking on the article and reading more about it if you are interested in. The second site is an application that uses computer vision and image captioning models to sort of give you like a tour of where you're walking around. So this is really useful for visually impaired people, as well as maybe if you're touring a new city. So what it would do is it is just like an image captioning model that views the landscape and then describes to you what you're seeing. They also discuss scaling Bayesian neural network models. So Bayesian neural network models are this idea of, rather than having a fixed set of weights for all the parameters of a neural network, you have a distribution, like a posterior distribution on all the weights that is learned in the Bayesian network. And by having a distribution of the weights, you can get really good uncertainty estimates when you're doing predictions. And as they mentioned in the batch, this is really useful for things like self-driving cars and medical imaging. Thanks for watching this edition of AI Research Weekly Update, September 1st, 2019 from Henry AI Labs. Please subscribe for more deep learning and AI videos.